Hi everyone, today we are going to study coupling. So the concept of coupling says that the dependency between modules should be minimum. That means modules should not be dependent upon each other. They should exist as independent entities. So when they are less dependent upon each other, this means we are designing modules in such a way that would require to communicate frequently with each other. When there is lesser dependency, that means how would they interact or coexist in that system? They would exist by communicating frequently with each other. Now this communication between modules should be through parameters. How should two different modules communicate? Through parameters. Like in two functions, one function is calling the other function by passing what? Parameters. So this is the concept of communication between modules, because modules are nothing but the functions, and this communication, as I said, should be through parameter passing. Boolean variables or flags can be used for the purpose of communication. This is called coupling. How they should communicate with each other by passing parameters? What should be used as what should be the unit of parameters? You can use Boolean variables or flags. Basically, these flags are nothing but the Boolean variables that store information to control the flow of a program, or at times indicate the status of an operation. So they are known Boolean variables because at any given point of time they can store only two values, either true or false. So this is the whole concept of coupling. Coupling between modules should be minimum. As I said, coupling indicates the dependency between modules, and as I said that the dependency should be minimum. So what does this mean? This means that the coupling between modules should be minimum. Now, the reason for stressing the need for minimum dependence between modules is that if module 1 is largely dependent on another module 2, this will affect the functionality of module 1, because for every little thing module 1 will have to look up to module 2. So this will hamper the performance of module 1, because for every little thing, every functionality of its own, it has to look upon module 2. So this is one reason why we stress on less dependency or minimum coupling. Apart from this reason, the other reason or the other problem with dependency is that one module is when it is dependent upon another module, then there is problem related to maintenance, because if one module has to be maintained, then the other module upon which it is dependent, that will also have to be maintained. So again, there is a problem when it comes to maintenance also. Now, if a programmer has to change the functionality of one module, then he should also make necessary changes to the internals of the modules on which the module in question is largely dependent. Right, because while maintaining, when you have to make changes to a certain module, and if it is dependent upon another module, then you will have to make changes to that module also on which the module in question is dependent. So this is quite a tedious task. Now let's discuss the different types of coupling. The different types of coupling, first one is your data coupling. Now in data coupling, communication between modules is through passing of data as parameters. Now what is the unit of parameter here? What is being passed as parameter? Data. Actual data is being passed as parameter between the modules for communication in case of data coupling. The other alternative in this type of coupling is the usage of flags. The one alternative is that you pass data as parameters, and the other alternative is that instead of data, you can pass flags as parameters, right? So one module will not be and need not be aware of the internal structure of the module with which it is communicating. Two modules are simply communicating either by passing data or flags, hence they do not need to be aware of each other's internal structure, which is very important to maintain privacy. Now, as we are discussing flags, you must know some important types of flags that exist. Besides these, there are other flags also, but we will be discussing the major ones. The first one is PSH. PSH instructs the operating system to send or receive data immediately. So the moment the system sees a PSH flag, it understands that there is an urgency, or there is a need to send or receive data immediately. The other one is the URG flag. It signals that the data is urgent and should be prioritized over non-urgent data. Now while you are sending data, there may be different types of data, a lot of data that needs to be sent. Now when there is some urgent data, the URG flag is used, which indicates that this particular piece of data is urgent, and as of now you must send this data first and ignore the other data that exists. ACK flag confirms that the previous segment was received. That means basically it is sending you an acknowledgement of the receipt of the data segment that has been received. The next flag is your FIN flag. Now the FIN flag indicates that the connection is terminating because there is no more data to transmit. So basically it tells you, okay, now we are about to terminate the connection. Why? Because we do not have any further data to be transmitted. The next is your RST flag that allows the connection to be terminated spontaneously. Now when an RST flag is received, that means both sides can spontaneously terminate the connection. Now after data coupling, the other type of coupling is your stamp coupling. Now in stamp coupling, the communication takes place by passing data structures. Unlike data coupling, in which we were passing data as parameter, in stamp coupling we are passing the entire data structures. Therefore it involves tramp data. Now what is tramp data? Tramp data is the data that is passed from one function or from one module to another function without being used by the first function. That means the function which is passing the data structure will not use that data structure, and that will be directly used by the function to which it is passed. Now the third kind of coupling is the control coupling. In the control coupling, if the modules communicate by passing control information, that is why the name control coupling, because what is being passed as parameter for the communication between modules, control information is being passed, and such modules are said to be control coupled. Now of course it can be bad if the parameters, that means the control information, indicates completely different behavior, and it is a good sign if the control information which is being passed as parameters here allows factoring. Factoring means the ability to divide a system into various modules and reuse of functionality. Example of control coupling is a sort function that takes comparison function as an argument. Now you know a sort function will do sorting of data. To do sorting, it will require to do comparison. So instead of doing the comparison in the sort function itself, you make a separate comparison function, and this sort function, while doing the sorting, takes this comparison function as an argument. So this is the example of control coupling. The next kind of coupling is the external coupling. In external coupling, the modules external to the software being developed or to a particular type of hardware are shared. That means the modules which are not internal to the software. Modules which are internal to the software are the ones which are being specifically made for that software. But there may be some modules which exist out of the software, and they may be needed at times. So in external coupling, such kind of modules which are external to the software being developed are shared. Examples include certain protocols which can be common to more than one software, external files which can be common to more than one software, or device format, etc. Then is your common coupling. What is common coupling? The modules share data such as global data structures. Now there are some global data structures which are meant for all the modules. That means all the modules can share those data structures. Such kind of data structures which are not internal to a specific module but can are declared outside the modules are known as the global data structures. So the modules, when they share data such as global data structure, this is called common coupling. Now any changes in the global data means tracking back to all the modules which access that data to evaluate the effect of change, because these global data structures are not internal to a specific module. So if there is any change that is made in a global data structure, that means all those modules which are using this particular global data, they need to be tracked back, so that the data that has to be evaluated and the effect of change can be evaluated. So it has got disadvantage like difficulty in reusing modules, reduced ability to control data access, and reduced maintainability. Then is your content coupling. In content coupling, one module can modify the data of another module, or control flow is passed from one module to other module. You are directly passing the control flow, or you can change the data. One module can change the data of another module. This is the concept of content coupling, and of course this is not a desirable thing. So this is the first form of coupling and should be avoided. The last kind of coupling that we will be studying is the temporal coupling. In temporal coupling, when two modules depend upon the timing or order of events, one module is depend upon the timing of another module or the order of events of another module. Say for example, module 2 will be executed only when module 1 is being executed. So such kind of coupling refers to temporal coupling. That means one module needs to execute before the another. So this type of coupling can result in design issues, because first of all, during design you will have to decide which module to design first. You do not have the liberty to design any module at any given point of time. Rather you'll have to decide which module to design first. And of course there are difficulties in testing also, because you cannot test module 2 before testing module 1. So again there is a lot of dependency in testing and maintenance also. So this was all about coupling. I hope you understood.